Okay, next we're going to do the same thing, but we're going to be using G instead of F. So we're using the same interval. So we're going to start with -2, but we're doing G. So G of -2 would go in as 2 times -2 squared plus 1. Please put parentheses around your inputs because it will help you remember that you're actually not just squaring 2, but you're squaring -2. -2 squared is +4. 4 times 2 is 8 plus 1 is 9. So the output for -2 is 9. Now we're going to do the other end of the interval, which was 3. So G of 3 turns out to be 2 times 3 squared plus 1. 3 squared is 9 times 2 is 18 plus 1 is 19. So now I'm going to use these two outputs with these two inputs to find my average rate of change. So that's delta G over delta X. So that would be, and again, it doesn't matter who you do first. I usually just do the bigger positive number first. So that's 19 minus 9. And because I started with 19 as the output, I have to start with that output's input, which was 3, minus a -2. Be careful with those negatives. When the second number is negative, it's really a minus minus, which turns into a positive. So 19 minus 9 is 10. 3 plus 2 is 5. 10 divided by 5 is 2. So therefore, the average rate of change is 2. Now, you will know that if you graph function g, it's a parabola, which means it's not going to have a constant rate of change. It would just be an average rate of change. So on average, from -2 to 3, we are increasing each time we move over by 2. It won't be exactly 2 every time. Remember, it's just an average. Okay, so example 2. This one's a little more difficult. There's a little more work to do with this. So this one says that the table below represents, and this is huge, this is very important, it's a linear function, which means it's a line. You see the word line in there. Linear means line, which means there will be a constant rate of change, which means there will be a slope, like we've done in the past. So you have to think back to yourself. This is going to look like, we're going to have to come up with this equation because we have to fill in the missing parts of this table. So we have to come up with the missing x's and y's. Well, to do that, you need to know your equation of your line. So first thing we're going to find is our slope, our m, our rate of change. So to do that, we just need 2 points. So we got to know the x and the y of 2 points, not just one, and we happen to. We know this point, 1, -5, and this point, 5, 1. So on top, you're going to subtract the outputs, which are the y's. It does not matter who you do first. In fact, I'll switch it up this time. I'm going to do -5 minus 1. Those are my 2 y's. And then I have to subtract on the bottom my inputs, or my x's that go with those 2 y's. So because I started with -5, I have to start with 1. So I'm going to do 1 minus 5. So -5 minus 1 is -6. 1 minus 5 is -4. A negative over a negative is a positive. And then that fraction reduced is 3/2. I'm going to leave it as 3/2. Don't turn it into a decimal. Well, now I have to find the y-intercept because I don't know if it's a constant, if it goes through the origin or not. I can't assume that it will. So basically what's missing, the y-intercept is when x is 0. So I'm trying to find what the y-intercept will be when x is 0. Well, it's not going to be a nice number, I'll tell you right now. So to do that, here's what you're going to do. We now know m. We need to find b. We also happen to know multiple x's and y's that we could plug in for x and y. We know at least 2 points right here that we could plug in for x and y. It does not matter who you use. I'm going to use 5, 1 just because they're both positive. So I know what m is. I know a point. I know that when x is 5, y is 1. So I'm going to plug those in to y equals mx plus b and solve for b. So I'm going to plug in 1 for y. M I found to be 3/2. X is 5. plus I don't know b, so I'm going to leave it as b. That might look like a 6, but that's a b. Now when I multiply and solve for b, I'm going to get b alone. So 5 times 3 is 15, divided by 2 is 7.5. And then when I get b alone, I'm going to subtract the 7.5 over to the other side. So b, unfortunately, it turns out to be not that nice of a number, but it's negative 6.5, which isn't too terrible. So now I know the equation of the line that would give me these points up here in this table. It would be y equals 3/2 x minus 6.5. To check, you should check if you did that right by simply plugging in these two x's that we know and making sure we get these two y's, which we do. I've already checked. So now I'm going to use this formula, or this equation, sorry, to plug in my x's to find their missing y's, and then similarly my y to find his missing x. So first, if you plug in 11, you're going to do 3/2 times 11 minus 6.5. Use your calculator. It turns out to be 10. Then you would plug in 45, so 3/2 times 45 minus 6.5. Whoops, I'm going off the paper, 6.5. That turns out to be 61. And then the last one, you're actually going to plug in 22 for y this time because it's a y value. So you're going to have to do a little more work because you're going to have to get x alone. So you're going to add the 6.5 over to the other side, then multiply the 2 over, then divide by 3. It turns out to be 19. So there you have it. There is your lesson on average rate of change. Remember, it is called average rate of change, especially for different graphs that aren't straight lines like parabolas or exponential graphs or whatever else we're doing this year, because it's not going to be a constant rate. So they will give you, most likely anyway, an interval that you have to work with. And you're going to have to plug those x values in to find the y's so that you can then use the average rate of change formula. If you have any questions, please let me know next class. Okay, the next video is on lesson 3.2, average rate of change. So you have seen this before, whether you remember it or not. You have talked about the average rate of change in terms of the slope of a straight line. But this lesson, we are not just working with straight lines. We are going to be working with things like parabolas, and those don't have a constant rate of change. That's why we use the word average rate of change, because it won't be the same in every interval. So therefore, if it is not a straight line, they will tell you, even if it is a straight line, they may tell you an interval on which to find the average rate of change for. Okay, so with that being said, it is very similar to the slope. In fact, it's the same as the slope formula. You're finding the change in the outputs. And if you think of the word change, when you go to a store and they give you your change, they took what you owed and what you gave them and they subtracted. So whenever you hear the word change in math, you should be thinking subtraction. So you're going to subtract the two outputs between whatever the interval is that they gave you. So you have to maybe find those outputs first. So you're going to subtract those values and you're going to divide on the bottom by the subtraction of the inputs that go with those outputs. Now you just have to be careful that you subtract in the same order on the bottom as you did on the top. So again, if you started with B on the top, B's output, you have to start with B's input on the bottom. You don't have to start with B. You could have started with A on the top, but then you'd have to start with A on the bottom. So remember, outputs are your Y's, inputs are your X's. So let's do the first example. It says, consider the following two functions. F of x is 5x plus 7, and g of x is 2x squared plus 1. Calculate the average rate of change for both functions over the same interval from -2 to 3. So first let's do f of x. So we know that the inputs are -2 to 3. And we got to find the outputs that go with those inputs so that we can use them in our formula. So we have to do like a little bit of side work first. So first we're going to figure out what f of negative 2 turns out to be when I plug it into my function. So that's 5 times negative 2 plus 7. So that's negative 10 plus 7 is negative 3. So that's your output when your input is negative 2. Now we're going to find our output when our input is positive 3 because that was the upper end of the interval. So that's 5 times 3 plus 7, which is 22. So there's your other output. So now to find the average rate of change, which is delta, that symbol is delta, which means change in f over the change in x, you're going to take the outputs on top and subtract them. It does not matter who goes first. I'm going to do 22 first. So that's 22 minus a negative 3. Be careful because that's a minus minus. And then on the bottom, because I started with 22, I have to start with his input, which was 3, minus the other input, which was negative 2. Now be careful because minus minuses turn into pluses. So that's 25 over 5, which reduces to 5. Welcome to lesson 3.1 on proportional or direct relationships. Proportional or direct relationships involve two variables. It is usually x and y, but doesn't necessarily have to be x and y. And they will have a direct or proportional relationship if for every ordered pair, x, y, we have y divided by x is equal to some number k, or if we manipulate this, it would be y equals k times x. You can think of this, if you were to graph y equals k times x, as a straight line through the origin. It's through the origin because there is no y-intercept. There is no plus b. Through origin. K, if you continue reading, is known as the constant of variation. So it is a constant number, similar to the slope in your straight line. So K in the past would have been written like this, y equals m times x, but it is now called K. So it is just a number, it is a constant. So we're going to do a few examples where you are given one data point, you're given an x and a y, and you're going to have to find K, the constant, and then use that to find a missing variable, either x or y. So in example 1, they tell you that the variables x and y are directly related. That's important that we know they are directly related, which means there is a constant of variation, and we can find that. So we're going to solve for the missing value, which in this case is y. So step number 1, you have to first find K. So to do that, we're going to use the point they gave us. They gave us x is 5 and y is 15. So therefore, I'm going to use this version quite a bit, just because that's the one that I remember the most. So I'm going to rewrite it, y equals k times x, and I'm going to plug in what I know. I know y is 15, I don't know k, and I know x is 5. In our heads, we can probably do this in our heads, we know that k is going to turn out to be 3. If you divide the 5 over, k turns out to be 3. Now we're going to use that in step 2. Now that we know that k is 3, we're going to use our x equals 9 to solve for y. So again, I'm going to rewrite this, y equals k times x. I don't know what y is, so I'm going to leave it as y. I just found k to be 3, and I know 9 is x. So now I can just simply multiply 3 times 9 to get my y. So y is 27. Similarly over here, it's a very similar type of question, except k, you will see, is going to turn out to be a fraction instead of a whole number like it was over here. So we, again, step 1, have to find k. So I'm going to use my y equals k times x, plug in y is 12, I don't know k, and and x is 16. Now when you solve for k, you're going to divide the 16 over, and 12 cannot be divided by 16 to get an integer or a whole number. So we're going to reduce that though. 12 over 16, you can divide out a 4 from both of those, so k turns out to be 3/4 or 0.75. So now in step 2, I'm going to use k to solve for y. So that's y equals 3/4, which is k, times x, which is 24. So when you multiply 3/4 by 24, you get 18. So y turns out to be 18. All right, last example is a word problem, and it's going to involve direct variation. So it says Jenna works a job where her pay varies directly with the number of hours she has worked. In 1 week, she worked 35 hours and made $274.75. How many hours would she need to work? So we're trying to solve for hours in order to earn $337.55. So you can think of this as the money is equal to some constant k times the hours. So we can figure out our constant k because we know how much she made when she worked 35 hours. So you're basically trying to figure out her hourly rate. So she made $274.75. We don't know her hourly rate yet, but we know that she worked for 35 hours. So now when you solve for k, you're going to divide the 35 over to the other side, and it turns out to be $7.85. Now I can use that k to figure out how many hours she would need to work to make this much money. So this time I know the amount, $337.55, is equal to, the rate is $7.85 times some number h. So we're going to solve for h by dividing the 7.85 over to the other side, and we end up getting 43 hours. Oh, not x, I used h. H equals 43. And there you have it. So direct variation, make sure in the question it does say they vary directly, and you just have to set up your y equals k times x and solve for k if necessary before you can solve for x or y.